Okay. All right. Makes sense. So now, welcome to class, everyone. Welcome, welcome, welcome. So today we'll be looking at optical instruments, and for optical instruments, we're going to be looking at things around. I think I should make a reference to that. We're going to make you check out your simple microscope. All right, we have simple microscope, and we'll see how it works and the principles. We have the compound microscope. After that, after the compound microscope, we'll look at telescope. Yeah, so under telescope, we have different kinds of telescope, right? And I think after that, we'll also look at eye defects. Okay, we'll look at eye defects. We'll look at the camera, all right? Then we'll look at calculations under that. So these are the key things we'll be looking at in today's class because we've done things on reflection for mirrors, reflection in lenses. So it now culminates into the kind of instruments that we can actually work on using the idea of a mirror, right? Using the idea of lens. So everything works around this. All right. So that said, let's get started. So now the first one is your simple microscope. All right. Now, the simple microscope is more like what we know already. I can remember back in my 100 level, they said we should make use of students can be funny, So the microscope, then they said we should look through the microscope. That was biology practical by 101. So we should now highlight the enzymes. Is it enzymes? I think bacteria that we saw. So people will look through the microscope. They say they are not seeing anything. Do you know people ended up going online to browse bacteria, but they gave you a specimen, something that you should look at, and now tell them the name of the bacteria. People went online. I followed them. I copied now because when you have you have we have up to like 300 students inside one place. People you can't even have access. People that are looking at the microscope say they are not seeing anything. They're not seeing any bacteria. And then we eventually went online to start browsing bacteria to draw. And at the end of the day, I think I had 14 over 20 in that practical. I wonder how this score came about. That's the system we find ourselves anyway. So for your simple microscope is when an object is placed between the principal focus and the optical center, you know already, right, of a converging lens, that the image is usually what? Enlarged. We studied that when we looked at lenses, erect and what? Virtual, right? That's the kind of image that is formed when we place the object between the principal focus, right, and which other one? Between the principal focus and the optical center. So once we place the object there, that's the kind of image that is formed, right? So the converging lens used in this way is actually what brings about the microscope, the simple microscope. Is that okay? Does it make sense? Uh, uh, mm, all right. So now, a simple microscope, in simple terms, is simply when you have the object, right, placed between the principal focus and the optical center. So when we want to form that kind of object or instrument, I mean to say, that is the principle behind it. All right. So a concave, a converging lens used in this way constitutes a simple microscope or a magnifying glass. I think I shared in this class the last time. The first Bible I bought for myself was in 2017, was a small pocket Bible, and it has magnifying glass inside of it, right? A very small pocket Bible, but it has something. The glass is more like very slim, like the thickness is not much. So when you bring it to a particular thing, it actually amplifies it because that Bible is very small and the text is very very tiny. I don't know what happened. I went to church the other day, some time ago, and it didn't return with me. I don't know what happened. I won't say they stole it. Maybe they kept it well for me in church. I can't say that they stole it. I don't want to believe that. But that was the last time I saw that magnifying glass. Funny enough, I still went again. Did I buy a new? Okay, I don't think I bought it. I've not bought a new Bible since then. I'll be using that one since 2017. So, but that glass was no longer there. I don't know if you've seen a magnifying glass before, but it actually serves very well. It's a very good instrument that explains this. Now, to now obtain higher degree of magnification, we've agreed that the other ones are quite tiny. It will not give us what we need, right? They are quite tiny. So to achieve a more higher degree of magnification, we now combine lenses together. Remember, the other one was making use of just one lens, but this time around now you are combining the lenses together, all right? And that will give birth to this instrument, the compound microscope, the telescope, and the prism binoculars, right? So these instruments are produced or are formed based on the principles of combining lenses together. Remember, simple microscope, just one lens, one converging lens. Object is placed between the principal focus and the optical center, and the image is magnified. An erect image, large and virtual image is formed, just like what we learned in our converging lens the last time. All right. So now let's go into compound microscope. Now, for JAM, these are things they ask of for the right way to use this your UTME exams. It's just that they want to know the key things you can remember. Basically, just a few questions on this. So now, to have a greater magnification than what? This one has greater magnification than what? Than simple microscope, right? That's what I wrote. And then is a combination of what? Two converging lens. Combination of what? Two converging lens. Take note of that. So for your compound microscope, we are bringing together two converging lens. One of them is what we call the objective lens. Then the second one is what we call the eyepiece lens. All right. So we are bringing together two kinds of lens. That's what we make use of for that very one. Is that okay? All right. So now, both lenses have short focal length. Both of them is going to have short focal length. All right. So both lenses have short focal length. Take note, because you start seeing things on telescope and you see how we keep modifying the telescope. The other one has this, lower this, bigger this, just that way. It's important to always take note of that. So objective lens, short focal length, the eyepiece, short focal length. So what kind of image is formed? The image formed is actually magnified, but it is a virtual image. Magnified, but what? But virtual. All right. So now, how do we get the magnifying power? To get the magnifying power, we multiply what do you call it? The magnification coming from the other one, which is your objective lens, with the one coming from the what do you call it? The objective lens and the eyepiece lens. So it's more like bringing both of them together, right? So when you bring both of them together, it gives you the magnification power for a compound microscope. So they're going to give you the value for the objective lens and the value for the eyepiece lens. So when you bring both of them together by multiplication, you now have your magnifying power for a simple, for a compound microscope. All right. So the next one is now your telescope. Actually, I shouldn't have written this astronomical telescope. You should have been just telescope. So I think it's better to just call it telescope, and then we'll take it off from there. So let's just write it telescope. So this should just be telescope, so that you can easily remember it. That's why I structured it that way, so we can remember easily. So we'll have our telescope. Now, so for the telescope, a telescope is an instrument that is used what? For viewing a distant object. Is kind of long. I don't know if you've seen those things. It's kind of long. If you watch military movies so much, some of those old military movies, you see those long one, very long, not that small one. No. There's a long one they normally use, right? So use it to view distant objects such as the stars and other blah blah blah. So and the telescope are of different forms. We have the astronomical telescope, we have the Galilean telescope, we have the terrestrial telescope, and then we have your prism binoculars. There's something we call Sophia as children. That small thing we call them. I think we call it Sophia or something in Igbo land. Like that thing that they too. It has. Do you know what I'm talking about, guys? Even in the recent movies, you see that, right? Those binoculars that they just put. When I was much younger, we called it Sophia, something Sophia or Sophia. That's how we call it back then. Without knowing the real names of some of those things. So now these are the key, and that one is a bit smaller. All right. I wish I can just show a little bit of things on that so you can see how it works. So now these are the forms of what the different kinds of telescope that we have. All right.
So the astronomical telescope, Galilean telescope. So now astronomical telescope is the simplest telescope, and then it was modified. The modified version is the Galilean telescope, followed by terrestrial telescope, then followed by the prism binoculars. We're going to look at. I've sent the questions to the group. Okay, well done, Paul. Thank you. So now we're going to look at the key changes that happened there, right, for each of them, from the astronomical telescope to the Galilean telescope to the terrestrial telescope to the prism binoculars. So we're going to look at what are those things that happened right there for their transformations. So first off, let's look at our astronomical telescope. So now for astronomical telescope, it has two lenses as always. Remember that those ones, like I said, your compound microscope and your telescope is formed by combining two lenses, an objective lens and an eyepiece lens. And those two lenses must not be the same. One can be a converging lens, the other can be a diverging lens. So it's so possible that both of them can be both diverging and both converging lens. Okay, both can be converging lens and they can also be converging and diverging. So it's not a must that when you hear objective lens, you start thinking that, oh, that one is converging. No, it is just objective and what's the name of the other one? An objective and eyepiece lens, which can either be a converging lens or a divergent lens. It all depends on the instrument that it is being applied on. All right. So now, but for the astronomical telescope, which is the simplest telescope we have, the objective lens usually has a long focal length. Long focal, and it's a converging lens actually. It is a converging lens. It has long focal length and it has the objective lens has a long focal length, while the eyepiece lens has a short focal length. All right, and both of them are actually converging lens. Now, the kind of image that is formed by this telescope is an inverted image and is also magnified. As always, we should know that it's going to be magnified, but I want you to pay attention to the fact that the image is inverted. Pay attention to the fact, Rachel, can you mute yourself, please? Pay attention to the fact that the image is what inverted for your astronomical telescope, which is the simplest form of your telescope. Now, the next key information we need to know, okay, I said note that the lenses can be arranged so that the final image is at infinity. These are key points I want you to remember, right? In that kind of arrangement, we call it the telescope in normal adjustment. So if the telescope is in normal adjustment, it simply means that you've arranged it in a way that the image is formed at infinity. Remember what we learned during what do you call it? The refraction of light in a plane mirror and the reflection of light when we did for lenses. You saw something that once you place the object at the principal focus, what happens? Image is formed at infinity. If you can still remember that at any point in time where we place an object at the principal focus or at the focal length, what happens is that the image is formed at infinity. So in that case, for a telescope, we say that that telescope is in a normal adjustment. So at normal adjustment, the image of a telescope, the object is placed at the principal focus, and the image will be formed at infinity. That is for your what? Your normal adjustment for your telescope. Does that make sense, guys? Give me a thumbs up if you are following. Can I get a thumbs up if you're following? All right, great. Great. All right, so let's proceed. Yeah. So now let's now talk about the Galilean telescope. Sorry, the Galilean telescope. So now for the Galilean telescope, the same thing. You have the objective lens and the eyepiece lens. But now observe what is happening. Now, the reason why we had that is because for your first one, which is your astronomical telescope, the image formed is inverted. So now, but Galileo corrected that very error or that very challenge with the first telescope by now ensuring that the two lens, one is a converging lens, the other is a diverging lens. But for astronomical, both of them were converging lens, and that gave birth to us having an image that is inverted. So now, but for the Galilean telescope, two things were altered. Number one, the kind of lens that was used. We have a convergent lens, which is your objective lens, and we have a divergent lens, which is your eyepiece lens. Also, for the objective lens, the focal length is larger, right? While for the other guy, it is shorter. Look at it here. And remember for this one, we said that the same thing happens here. Long focal length, short focal length. The difference lies in the fact that for the first type, we had only a convergent lens. For the second type, we are bringing both a converging lens and a divergent lens, right? Converging for the objective lens, diverging for the other guy, which is your eyepiece. All right. So that said, we could move further. So what kind of image is formed by a Galilean telescope or Galilean telescope? Man of Galilee, Galilean. All right. So now it's also a virtual image. The image is erect, and as always, we're expecting the image to be magnified. Now we look at the magnifying power of both telescope. Now, whether you are using astronomical telescope or you are using your Galilean telescope, the magnifying power is simply the focal length of the objective lens over the focal length of the eyepiece. So these formulas are what taking note of, right? And I'm glad that Paul has sent some questions across to us so we can get our hands dirty. Very important formula that I think we should take note of at this point. All right. So I've explained the first kind of telescope, which is the astronomical telescope. I've also explained the second type, which is your, what do you call it? The terrestrial telescope. I didn't go into details to start telling you how those images are formed because of what? Your UTME questions, they don't care to know how the principle or the mechanism. It's just your ability to recall some of these things. And that's why I'm putting it down the way I'm doing. Now, the next one is your terrestrial. Am I pronouncing this thing very well? Is it terrestrial? Terrestrial habitant, terrestrial telescope. Right, I'm correct, isn't it? Good. Now, the terrestrial telescope is also an astronomical telescope. Now, but this time around, it has additional lens in the middle. All right, to do what? To reinvert that image so that it is erect. So that is the key thing about your what? Your terrestrial telescope. I think is there an error there for Galileo? Is the image by Galileo erect? I don't think the Galilean telescope should be erect since we are correcting that using the terrestrial microscope or telescope rather. Are they usually inverted? Sorry, let me be sure, please. Okay, yeah, I'm correct. Someone messaged. What was the message? Sorry, I didn't see that message. Let me check. Upright. Okay. Upright. Meso, thank you. Meso the scientist. I'm rooting for you. All right. So the image is erect, like I said. Okay, so let's proceed. We have the terrestrial telescope now. Additional lens in the middle to reinvert the image so that the image is erect. All right. So now, but this time around, the terrestrial telescope is now longer than the astronomical telescope because of the additional lens, right? So now, remember that the telescope is already a long instrument. So now, putting additional lens, that means the terrestrial telescope and the Galilean telescope are simply modifications of the astronomical telescope, each having its own challenges. Now, with the terrestrial, it is now longer. It is still having that issue of height. The issues of height are still there, all right, for the terrestrial telescope. All right. Now, the image formed is the same as the astronomical telescope. The difference lies in the fact that it is erect. Remember, for the astronomical telescope, we said that the image is inverted and the image is magnified. Right. These are two key details we had for the astronomical. So now, but for terrestrial now, it is still the same thing. Difference lies in the fact that is what the image will be inverted, but the problem of length is what comes into play. It's a bit longer. The instrument is long. Putting additional lens at the center will still increase the length further. All right. So now, but the problem of length in the terrestrial telescope was actually corrected using what we call the prism binoculars, right? So this was actually corrected. That issue of length was corrected using this guy. So anytime you see a question alongside telescope and then reducing the length of this instrument, it was the prism binoculars that came to the rescue to ensure that the length is no longer a problem, all right? Serving the same purpose, but at this point in time with a shorter length. Okay, that said, the prism binoculars work on the same principle as the astronomical telescope. But this time around, it actually makes use of a total reflecting prism all right, combined with a convergent lens. This is all you need to remember. Because if you check past questions, nobody's going into detail to ask you, why is this one this way? Why is this one this way? These are just the key concepts they need you to recall. If eventually questions come from this part of physics, right? So that's the process you're going to follow to answer your questions. Now, I have some things here I want you to do on your own because I'm not strong in biology so much. I'm not even so much. I'm not strong at all when it comes to biology. So now, study the human eye and how we see. And I think they taught you guys already. I think Mr. Kule taught you guys. Someone is laughing at me. I'm not strong at all when it comes to biology. And as a matter of fact, I don't think, have I read topics? Okay, it was in my 100 level. They forced us to do biology. You had biology, bio 101. And that was the first time in my entire life I sat down to read a biology textbook. I'm serious. That's the very first time in my entire life I sat down to read biology textbook. Because I was lucky enough during WAEC, biology was not compulsory for science students. I knew I was going for engineering. So in place of biology, I actually did agric. Right. So there's no idea. So then go and study about the eyes and how we see. Then there's something we call persistence of vision. Persistence. They ask that question a lot as well. So just understand the mechanism behind it. And then the concept of accommodation. The reason why your eyes will adjust for you to see a distance further. So in camera, they adjust the lenses. You hear bam, bam, isn't it? I know you don't know how to use camera. All right. But Mr. Kunle will teach you guys. Now, when you adjust the distance, your eyes, you cannot adjust your own lenses, but there's something we call accommodation. God is wonderful. So now, that accommodation of the eyes, it does the same thing as someone adjusting the lenses of a camera, right? That adjusting. The accommodation of the eyes is exactly the same principle, right? So go ahead and check about the persistence of vision and the concept of accommodation. But if eventually I happen to see questions on that from the questions that Paul sent to us, then I will not be forced to do that for you guys. But I pray I won't see any of them. So you guys will go and do your assignment. If you are with me, say amen. All right. Let's look at normal vision and the defects of vision, right? So now, for someone with normal vision, the nearest distance at which objects can comfortably be seen is about 25 centimeter. All right. So now, if for me to see something very well, I cannot bring it closer like this. It's not possible. Unless if I start bringing things closer like this, two things are involved, and I will not mention the name. Two things are involved. Should I have eye problem or otabagenanya? Like, so these are the two conditions, right? So when I said sorry, Paul, when I mean someone that is so fair that it now entered their eyes, So that's why you see them; they'll come closer to see the stuff this way. So, but the nearest distance at which object can comfortably be seen is 25 centimeter. If the object is 25 cm away, yeah. I don't want to mention the name, right? So you don't have to mention the name, and so you don't become. All right. So 25 centimeter from the eye, you never can tell. You never can tell. So that's why I don't talk about it so much, because we are yet to marry, and we never can tell whether love will take us to one of them that way. All right. So until then, let's keep rolling, guys. All right. So that's a normal distance. The nearest distance at which we can see comfortably is 25 centimeter from the eyes. All right. And it's advisable to always keep that at 25 cm. So when you're bringing it closer, it's no longer healthy, right? So now, and the farthest distance is at infinity. That's the farthest you can see at infinity. All right. Now, there's now a name for each of these things, right? So the names now for the nearest point at which an object can be seen very well is what we regard as the near point. So it's regarded as what? As the near point. So that 25 centimeter is our near point, right? At which we can see very well. Then the farthest point is now what we regard as your what? As your far point. All right. It is known as your what? As your far point. So the clear vision, the farthest point you can see is your far point. The closest distance we can see is your what? Is your near point. But sometimes there can be eye defects. All right. We can see people that they don't see things that are very far. If it is very far, they cannot see. Why there are people that they cannot see something that is close. And that is why people, they will now they'll have to bring it, so that they can see whatever that is there, right? Good. So, but that's why there are glasses. You have glasses, right? To correct some of those things. I can remember there's a woman I saw. She said I should help her. I was also the woman like, I was so surprised. How is the woman seeing like this way, very close to? She wants to bring out one phone number from her, and that was a button phone anyway. So that was when I said, let me assist you because I saw how the whole thing was happening, right? So these are eye defects. Some of them come naturally, some of them are because of how people have stretched the eyes, right? And that's why I said I need to get these glasses now because we stay so much on the screen. So I will not get to that age now. I'll be doing like this. So to avoid those kind of things, too much when you know that you expose yourself so much to the screen, it's important you buy some of those anti-blurry glasses to preserve and help your eyes. So I'll also be very careful on. That's why they say don't stay too much close to the screen. So these are some of those things. Don't read with candle light, and the rest of them. So these are things that can actually cause damages to the eyes. But that's not our concern for today. Why there are people that are born naturally that way, especially those people that have that albinism, right? And I think in biology, you guys can actually say something regarding it, right? Yeah. I think it's about chromosomes, isn't it? I think I have biology guys in the class now. Yeah, I think I'm good already. I said I don't know biology. I'm talking about chromosomes. Yeah. Can you imagine? Yeah, talking about chromosomes. I think X and Y chromosomes. So when that happens, some of those things comes into play. I think you guys will say I'm a bad man or a bad boy, right? The topic I enjoy so much in biology is reproduction. That's those most interesting topic everybody wants to listen to back in secondary school. Don't pretend as if you don't know what I'm talking about. So that topic, all the ears are open, everybody's paying attention. So that's the tendency anyway. So let's go. Let's proceed. Now we now have the long side and the short side. And then if you eventually have a woman teaching that biology, some of them can be so bold. They know how to explain. Like they can bisect, bring you and use example, They know how to teach those topics very well. All right. So we have the long side and then the short side. Now, the long side is more like the reverse is the case. This thing was confusing me before, like hyper what? Metropia, right? And then myopia, right? So myopia is short sight, then long sight is the hypermetropia, right? These are some of the things that chased me away from biology. Pronouncing those words, because when I was younger, even now, I think I talk faster. I talk very fast. So pronouncing those words was a problem. So I said, let me respect myself, right? And go to a place where you solve more of equations and not pronounce anything. I can remember this particular, I never see word exactly. This particular word when I was much younger. You see this word, this legislature, even till now to pronounce is a problem. If I'm reading back then, anywhere I see this word, my heart will skip. if I'm reading, well, anyway, I'm reading and I miss that thing, especially during those government, I will see wahala. So what I normally do is that once I get to that place, I will just jump it. Then people, maybe as you are reading it for people, they will not, how that kind of thing. They will think that it's a mistake, don't knowing that intentionally you skipped it, and people will not add it for you, right? So that was the strategy I was using back there for those words, So that's to tell you how bad it was. Pronouncing words was a big challenge because of how fast I talk, So that's entirely fine. So put that out into medicine, you guys are doing the best, right? Because by now, if I'm a medical doctor, I must have called one drug and the person will go and buy another thing altogether. So now for a long sight, they cannot see objects close to them. So long sight means just the name is the reverse is the case. You guys are still laughing at me. For the long sight, reverse is the case. So now long sight cannot see close objects very well. They cannot see close objects very well. That's for the long sight. Now, short sight cannot see objects that are very far. Reverse is the case. I think I argued this thing with someone sometime, but because the person studied some of those health this thing and it's been long I read about this, I think around 2018 or so. So when the person said no, I couldn't stand my ground because I wasn't too sure. And the place we were at the moment, there was no internet, right? You will not understand. You God grant you understand it. There was a place I was some time ago, right? The only place you see internet is inside the house. Once you're outside, you cannot use internet. So now, and I think the way I remember this is that if I'm talking about long sights, right? If I'm talking about long sight, it means you cannot see something close. Reverse is the case. Talking about short sight means you cannot see something that is far. Short sight now, which means the only thing you can see now the one where they close to you. Long sight means the only thing you can see now the one where they long or far from you. Does that make sense, guys? Hope nobody's confused. Just by the name, you can always remember. Now, for a long sight person, the near point is further away than the normal near point. Normal near point is 25 centimeter, but someone that has this eye defect, his own can be around 37. So their own is further away, right? So that is what we regard as a long sight. Now, for the short sight person, far point is less than normal, right? So now the far point, which is infinity, is less than normal. So that person cannot see a distant object. And that's why, like I said, the person will want to bring it closer to their eyes so they can see, because once it's far from them, they cannot see, right? Something has happened to their far point, all right? That's for your short sight. Now, another thing that happens to the long sight is that their eyeballs are too short, right? But I don't know how to explain this in Yoruba, right? But it simply means na kopa anya had the too short. You know, there's something they say in Igbo language, nanga kwagi kopa anya, right? Like, Paul, look at what I mean. I don't know how to explain this. Maybe you are fighting with someone, or just that kind of thing, or not even fighting, you're talking with someone. Then the person is going to blow out your eye socket. Have you heard that kind of thing before? That someone will give a kind of blow. In Igbo language, you call it anabia kopa anya. Yeah, you understand? All right. So when the eyeball is too short, that's because of what? Of your long sight. Then the eyeball is too long, right? That's because of short sight. Now, to do that, what happens is that the object is focused behind the retina. Behind the retina. But for short sight, in front of the retina. All right. To correct a long-sighted defect, we use the converging lens. And to correct a short-sighted person, we use the divergent lens. All right. So please, these are key points you should take note of. And I know that as we start answering past questions, we certainly are going to see some of those things, right? As we start answering questions, you're going to see them. All right. So the next one now is, I think I can remember seeing these questions in past, comparing the camera and the human eye. So for the camera, it has a film, and that film is light sensitive. I think this thing has not moved. Can you see my screen? From my end, I think it has not moved actually. All right, but from my end, it has not moved. Yeah, it hasn't moved from my end, which has something to do with my internet, basically. Yeah, now it has moved. I'm coming. Let me reduce the load on the internet. All right. So now it has a film that is what light sensitive. For our own eyes, it is the retina that is light sensitive. All right. Our own retina is light sensitive. All right. But for your camera, what is sensitive is the film. The film is sensitive. Is that okay, guys? I will follow you. Now, the next one is that the diaphragm. I will follow in. Diaphragm regulates the amount of light entering the camera. Then your iris, I think I've seen this question, I can remember 2017, will now regulate the amount of light that is entering your eyes. All right. So these are the key things we need to always remember regarding the camera, comparing the camera and the human eye. Now, but there are differences between them actually. What's the difference? Right? The key difference is that, are we together now? That the distance between the lens and the retina, good, in a human eye is fixed, right? The distance between the lens and the retina for human eyes is fixed actually. You cannot do anything. God has done it. And that is why if you keep thinking about what God has done, it blows your mind, right? So the distance between the lens and the retina is fixed in the human eye, right? The eye can, however, see objects at various distances using what we call accommodation. So distance between the lenses and the retina is fixed. But however, your eyes can see things at different distances. I can turn like this and see the thing there. I can go like this. My eyes can, without adjusting anything, right? That is by the power of accommodation, which is something that when you start thinking about what God did, like that's why we can trust Him. No matter what we think we're going through, no matter how difficult we think situations are. When you look at, remember that you can see, and remember the principles behind you seeing, then you have plenty reasons to know that you are not alone. All right. So I'm saying this to encourage someone in the house. For some of us that are scared about the exam, remember that He gave you eyes. All right. For the camera, the distance between the lens and the film can be adjusted, right? You can adjust the distance between the lens and the film. All right. So the first thing I said here, is it important for me to write this thing down? Should I? Okay, let me write. So the distance between the lens and retina is fixed. All right, it is fixed. But I say that the eyes can see distances by accommodation, right? Right, the eye, however, see at different distances by accommodation. All right, but for camera it is not fixed, isn't it? All right. Now the lens of human eye has a variable focal length, right? So the lens of a human eye, it has a variable focal length, but that of camera is fixed. But that of camera is fixed. Remember, for camera, distance adjusted or adjustable. All right, so these are the key points. Then the eye is natural, is man-made. Sorry, then the eyes is God-made. Why the camera is what? Is man-made. I think it's time to get our hands dirty with questions. All right, that's why you're laughing. It's time to get our hands with questions. Yeah, you don't need to eat now. Man shall not live by bread alone. All right, Rachel. You are in class, you are looking for food. As a student, yeah, you shouldn't be eating. You should read more. Read more. Try to be like me. Right. But please eat, oh, you get why. Paul will understand better. Do fasting and prayer. Yeah. For this exam, good. There's something I need to share with us as well. During my exams, I fasted as well. I'm serious. Yeah. Can remember. I fasted during the exams. Yeah, yes. I took time to pray about that exam, basically. And if I narrate the things that happened that period, you will actually understand that this guy really, really prayed about that exam. There are some happenings around my own exams, and that we are evident that actually I'm still sharing my screen. You guys will soon see my secrets. But hope you guys didn't see anything at the moment for that short time. I hope nobody saw anything, right? If you saw anything, please unsee it. Unsee it, please. Unsee it. At all. Okay, you didn't say anything at all. Thank you so much. Thank you. Don't see, please. Don't see, please. But anyway, there's nothing there actually. Eh, man, Paul, you came prepared with questions, though. Now I'm looking at you with one eye. Mesa says she's looking at me with one eye. Mesa, you don't trust me? Hmm? You should trust me, actually. You know, initially when I started classes with people, I normally share it that way. Then I realized that for security reasons, it's not good because the videos are there on YouTube and it's going to stay there for so many years, right? So I now have to take caution, right? In as much as there's nothing, but then I realized there's not a good one to always as I'm sharing the names of people are showing, you know. So and it's a video that will stay for a long time, even when I get old. My kids will be like, so you did some of these things. I'll be like, my bro, I did this, man. I did this, bro. Yeah. Yeah, that's why I like the fact that these videos are recorded, right? And that's why I try as well to always ensure my camera is on when I can do that, so that these are things you can watch so many years later and be like, yeah. I can remember paying this price, you know. So they say in a compound microscope, the objective and the eye focal length are what? I explained this. So in a compound microscope, what happens to the objective and the eyepiece focal length? Did anyone want to take note of that? I explained it here. These are the kind of questions they're going to ask, right? Anyone answering? The answer is here. For a compound microscope, right? We have that both lenses have what? They have short focal length. So that's the kind of question you're going to be seeing, because no one is testing to see whether you understand the principles. It's just ability to recall them. Exam here is about your recall power. How much can you remember, right? So for compound microscope, they have the same length. Are we together? Give me a thumbs up if you're following, right? So the two guys are the same. Can you still hear me? So they are what? They are the same. All right, beautiful. Now the next one said, when a telescope is in normal use, good. Normal adjustment. Normal adjustment. So these are the kind of question you'll be seeing. So when the telescope, microscope, no, this thing have not changed from my own screen. Network is dealing with me. For here, it has changed. The other side, it has not changed. I'm seeing the other slide. So when a telescope, let me be looking at this place. When a telescope is in normal use, the final image is at what? Anybody? Normal use, where is the final image? From what I explained. Who can still remember? Who can still remember? Remember I said that at that point, look at where I said it here. Look at where I highlighted it. So I said something about your normal telescope. Good. The lenses can be arranged so that the final image is as infinity. In such arrangement, the principal focus of the objective must coincide with that of the eyepiece. So at that point in time, we said that the telescope is a normal adjustment. So that happens at infinity, right? So which means that the answer here is that in the normal use, the final image is at what? At infinity. All right. So the answer here is infinity. All right. So now the next part of things is going to be the no, I'm in class. Yeah, I think I'm coming. All right, so let's continue. Can you hear me now? Can you hear me? Yeah, thank you. So now is at infinity. We've answered that very question. So the next one, for a short-sighted person, light rays from a point on a very distant object is focused where? For a short-sighted person. Remember, for long sight, image is formed behind the retina. For a short-sighted person, image is formed what? Object, not image. The object is focused behind the retina for a long-sighted person. For a short-sighted person, image is formed in front of the retina, isn't it now? So in front of what? The retina, all right? So please take note of that, in front of the retina. All right, so these are key things we need to always remember as long as these questions are consigned, right? Now, the next one says the arrangement above shows the prism arrangement in a what? Which one has this arrangement? I know I didn't give you guys the diagram, all right? But remember what I said, that the middle will have something that will be inverted. Are we together? So that diagram actually is for your what? Your binocular, right? Because it's going to reduce the size. Are we together now? It's going to reduce this. Even if you don't know, look at what they said here. Once you see this word prism, you know they're talking about what? The prism word, binocular, which reduces the size. The size. Take note of that diagram. I know I didn't give you guys a diagram, right? But at least I know you should be able to answer that particular question. Can you give me a thumbs up if you're still following me? Can I get a thumbs up if you're still following? Beautiful, Paul. All right, thanks you, Rachel. Mesha, are you there? All right, so the next one says, the part of the human eye that does similar work as the diaphragm. Can you, somebody pronounce that thing, please?
Diaphragm.
Of a that thing you said, yes, of a camera lens is what, right? So you have iris, the ciliary muscles, we have pupil, we have retina. So which one does the same work as what Rachel said? So which one does that work? From what I gave you guys, I think I highlighted it here, right? So remember I gave you guys, it says that they regulate the amount of eye entering the eyes, which is A. Thank you, Paul. All right, so this is A right here. Thank you, Meso. So sorry, I'm saying A and I'm marking D. So that's the word, the iris. All right. So that said, that thing you said exactly. The following are parts of the eyes. We have the retina. We have the pupil. We have the Hey, God of miracle. Yeah, I need to go back to primary school and learn how to pronounce things. We have the pupil, right? And then the iris. I think for me to pronounce better, I have to slow down my speech. I know I talk very fast. So I'm trying my best, actually. But like I say, it remains small for the stammer. It remains very small, right? Very small. We feed it for class 3 hours. Very small. I feel it equivalent, you know? Yeah, so thank God that I escaped it, right? The way I talk very fast, you know that is a narrow distance, right? So now, so the following are parts. He said C, okay? C, film for retina, pupil for the aperture, and then the diaphragm. Yeah, C is very correct. No, I didn't speak about the pupil in terms of relating with your aperture. I don't think I made reference to that for your camera, but I'm glad that she brought that into light. All right, so please take note of that. Very important comparison between the camera and the human eye. Remember, these are things that God created and gave us the ability to recreate. So it's some of those things that when we look at it, we are so excited at what the Lord has done for us. All right. Which of the following eye defects can be corrected using a clinical lens? You know that you cannot use myopia. You cannot use clinical lens to correct myopia. You cannot use. I think. Did I go deep into this? I think it should be astigmatism. Yeah. People that did biology. That's why I left you guys to study about the human eyes. Right. And I gave you guys that assignment. Right. It can be C, and you circled B. Which one? Which one did I circle a wrong thing? Can someone talk, please? Is there anyone I circled the wrong thing? I don't think so. All right. So now, good. Now, biology students in the house. Paul wants to study medicine. Mercer wants to study medicine. Please, can you guys? Rachel wants to study nursing. All of you are medical people. Can you tell us what is this astigmatism? What kind of defect is that? I know it has to do with old age, right? Just go ahead and someone should go ahead and tell us what the defect is. What kind of eye defect is this astigmatism? Someone should go ahead. Anybody that wants to talk?
Is an irregular shape of the cornea. That is the lens.
Okay.
It's from birth, actually.
Oh, okay. So what actually brings about it?
The lens are not like shaped properly. The shapes is not like it's not normal.
Does it come with old age?
No, it comes from birth.
From birth. Wow, interesting.
Yes.
All right, thank you. Irregular shape. Okay, thank you, medical doctors in the house. Thank you for helping an engineer that doesn't know anything on biology. Right? So that's entirely fine. Okay, let's proceed. Now, the next one is, and I think the textbook I used, right, this senior secondary school omitted some of these things. Senior secondary school went straight up, but your new school physics highlighted some of these eye defects. Senior secondary school went straight to the point, talk about that short-sighted, and they didn't actually go into detail to actually talk about astigmatism. I don't think they mentioned that, right? No, they didn't. All right, so let's proceed. Which part of the camera functions like the retina of the human eye? Retina is your film, isn't it? Yeah, someone can answer that. That should be your film, right? So the film acts at that. All right. I'm still looking for calculations, though. The ability of the human eye to focus object on the retina is referred to as the power of what? I think I explained it. That is where God finished work in our eyes. What God did there, my God, Kai.
Accommodation.
Accommodation. And then someone will tell me there is no God. Kai. Which of the following? I wish I had more time. You see how all the things I cover, you see them in your past question. Exactly. How many of you have noticed it? Yeah. So I wish I had more time because I take time to read the textbook, actually. I'm not kidding. I take time to read the textbook. For every topic I teach, I take time to sit down to read your textbook, right? It takes nothing to just, so that the question will be in line with what they ask. And then as I'm reading it now, do you know what it does for me? I'm remembering some of the questions I saw in 2017, right? Because so far it's been very long. I prepared people for JAM, very long, right? Very long. I think the last time was around 2019 or thereabouts. Yeah, I think so. So other exams has been, yeah, good to talk with us. Send me money, no be good, I go chop. Send me money. All right, so that's for that anyway. But I wish we had more time. Then I'm going to do that electricity so that as you are seeing those questions, you're going straight up. Now, which of the following is different between the human eye and the camera? What's the difference? The human eye has a lens, while a camera does not. The human eye has a diaphragm, blah, blah, blah. The human eye can focus on objects at different distances, while a camera cannot. So, which one? Which one, guys? Which one are we going for? Anybody? Yeah, C. Yeah. Remember what I said? I said that the distance between the lens and the retina is fixed in the human eye, right? But the eye can, however, see objects at various distances by the process of what? Accommodation, right? So the eye, in as much as distance is fixed, but by the process of accommodation, it can see different things at different distances. And the camera cannot do that, right? You have to be the one adjusting it, right? But for here, God is good, man. All right. So now, in projection lantern or focal length f, the object U is such that I didn't touch this part. That is how your slide projector. It is confusing. The question is confusing, right? Focal length f, the object is such that. Yeah. So, Paul, any idea on this question? I know I didn't touch that part of things. This particular question. In a projection lantern of focal length f, the object distance U is such that will be under projection, the slide projectors, right? But I thought that there is no question coming from that place for your slide projection. Okay. They said in a lantern projection focal length, the object distance U is such that object distance U, there's no detail. That's your assignment. Hey, all right. So go and check that lantern stuff. I think it should be your new school physics. All right. So check the lantern stuff. Now this one said a student viewing an object through a compound microscope. Right? A student viewing an object through a compound microscope. The distance between the object and the eyepiece is increased. What happens to the final image? So who can say something about this? Any answer? So what happens to the final image in this case? Secondary school. All right, can you guys still hear me, please? I think my messages are delayed. The message don't enter when you guys send it. My messages are delayed actually. All right, so let's go ahead and solve that question then. So the final image is no longer in focus for the observer. The magnification of what happens if the distance between the object and the focal length is increased. Now remember what I gave you guys here. Let's go back to that formula, right? I know some of you might not be able to connect what I'm saying, all right? So if you're increasing the image, the distance between them, remember there's a formula for the magnification I gave you guys, right? So I said that the focal length of the object over the focal length of, focal length of the objective lens over the focal length of the what? The eyepiece. Are you seeing it now? So it simply means that the up one is objective, down one is the eyepiece. Now, for us to answer that very question, hope we are following, guys. To answer that very question, where is the question again? All right, to answer that, if the distance between the objective and eyepiece is increased, right, what happens to the final image? Remember that we have looked at that very formula. The objective, your voice is cracking. I think my internet is actually breaking. Give me 2 seconds. Let me rectify that. Just 2 seconds. Let me quickly rectify that, please. Yeah, can you confirm you can hear me now? Okay. So I had to. Sorry, the MTN is not working actually. Yeah, let's just keep managing this. It's not working. All right, but you can still hear me, right? Can you still hear me? All right. MTN is actually having issues. I'm trying to see if I can top up that guy. All right. So they said the distance between the objective and eyepiece is increased. What happens to the final image? Right. So now what happens? Remember that both of them, yeah. Remember that compound microscope. What happens to a compound microscope? For a compound microscope, you could observe something that we said here, that the distances are the same for a compound microscope. That was one thing we established, right? That for compound microscope, they have the same, both lenses have what? They have short focal length. So what will happen if you increase the focal length of the other one? it's going to affect the image that will be produced, right? Now, and if you check, where is the question again? Once you stop hearing me, let me know, please. I'm still waiting to see if this thing can work through, so that we can have a better stuff. All right. So now, what will happen here is that because you've altered how the arrangement will be, right? The image, your answer will be that the image is no longer in focus for the observer. No, we don't have anything like migration. This doesn't happen. The final image moves closer to the eyepiece. No, will no longer be in focus for the observer. You're not going to see anything because you've altered how the arrangement should be in a compound microscope. They should have the same length. Are we together now? Both of them will have what? Short focal length. If you are following, give me a thumbs up. Richard, can you hear me very well now? Is it still cracking? Okay. Paul, go ahead and ask your question, brother.
Sir, this book I have here says their focal lengths are different.
Are different for compound microscope?
Yes.
Where? In your notes?
No.
Eh?
There's book I have here.
My own says for the compound microscope, right? They have short focal lengths. Because the objective lens and eyepiece, they have short focal lengths. So they have the same. Both of them have the same short focal length. You say, he said what?
It's saying the focal length. Let me read it. The objective length has a very small focal length and small aperture. Whereas the eyepiece has a relatively large focal length.
No, we are saying aperture. No. For compound microscope, these things are. It has both of them have short focal lengths.
I mean, they have short focal length, but I mean,
yes,
between the two of them, do they have the same focal length?
Between the two of them, no. For what we have, the explanation there is that both of them has what short focal length. You can see the modification now as they kept modifying it, and you check. There's a question we answered now for compound microscope. The eyepiece and objective lens. Sorry, objective lens and the eyepiece lens, they have same. That was the particular question. You saw that question here from your past question. So now, and it's very clear that as time went on, they start modifying it. When you now move over to the telescope, you start seeing that one of them had a larger focal length, while the other one has a short focal length. It's very clear. Which textbook are you using?
Extensive physics.
Expensive.
Extensive.
Okay, if you check, you know that if you remember something, it's important to remember that there's always your approved textbook, right? Are we together now?
Yes,
there's
sir.
always your approved textbook. When you go to your syllabus, you have your senior secondary school physics, you have your new school physics. These are two. You can check other ones as well, but I think they have their standard. And if you check, the questions are coming from those textbooks. Do you get the point? So now, whatever thing the man is saying, you need to pass your JAMB, okay? So just take note of that, because nobody will call you to start explaining why you chose that one. All right. So which of the following types of lens is suitable for correcting the eye defect illustrated by the ray diagram above? So what happens in this ray diagram here? Who can actually explain that? What do you think is happening here? Long-sightedness. So the image is formed what?
Behind the retina.
Behind the retina. Good. So when it forms behind the retina, how do you go about it? What lens do we use to actually correct long-sightedness?
I didn't know it contains big converging, as in biconverging. Which one is biconverging? I've not seen it before.
You don't need to stress yourself. The major thing there, once you see your converging, the other one said bidiverging. Biconverging is a kind of, I think I explained some of the kind of lens we had, right? Concave lens diverging, all right? Good. Now, long-sightedness, do we use converging or diverging lens?
It's converging.
It's converging lens, right? Good. So now, but you know, there are different kind of lens. I think I explained that in this class. There are different kinds of lens. Let me show you. We have the biconcave lens, biconvex. Let me show you guys. We did that. So when you see that, don't be confused about lenses. All you know is that it's a converging lens, but there are different kinds of converging lens. Now, I think it was reflection through lenses. These guys are yet to update this thing has been processing since then. Maybe they shall not eat my money without sending MTN data to me. Now, there are different types of lens, right? We have the biconvex, we have the piano-convex, we have the converging meniscus, right? So are you seeing it now? So it's a kind of converging lens. Can you see my screen now? We also have the different kinds of concave lens. I think I touched that as well for your concave diverging lens, right? I think I did, or didn't I? An enemy has done that. I didn't do that. I was thinking I explained the different kinds for each of them, but it happens that I didn't. All right. So I should have actually drawn as well for those guys, but these are the different kinds of converging lens that you have. All right. So you also have it for concave lens as well. Does that make sense? Good. We're looking at optical instruments. All right. So that's for that. So we're going to use what? A biconverging lens, because a converging lens will correct your long sight, while a diverging lens will correct your short sight. All right. So now the ability of the eye to focus on both near and far objects is called what? It is still the same thing. They are playing around things. They want to confuse you. So what will it be? Your answers, please. Your answers, please. B, accommodation. They are playing around words, okay? They are still talking about different distances, but somebody will see near and far. See which one be near and far or far again. Then this one said an astronomical telescope is said to be in normal adjustments when what happens? It said focal length of the object is longer than that of the eyepiece. Final image is at infinity. Eye is accommodated. So which one will it be, guys? Normal adjustments, Paul. What are these guys saying? Why you come, everybody is typing A? How? Is that what I taught you guys? How come you guys are saying A? There's something I said here. B, yeah, thank you, Meso. Why is everybody saying A? Yeah. Look at what I said about that. Look at what I said. They have to coincide now, right? They meet at a point. Not even shorter, no, nothing like shorter. Look at what I told you now. It's here, right? It can be arranged so that the final image is at infinity. In such arrangement, the principal focus of the objective lens is going to be with that of the eyepiece. That's what we said, right? To coincide with the other one. So that's the condition, right? Not even that this one will be shorter and longer than this. And the image is formed at infinity. So please, let's take note of that. All right. Next one. I think we stopped here. So we answered this. We said the image is at infinity, right? So now, the next one, in comparing camera and human eye, we've answered this thing before, is what? The film functions at your retina. I think they keep repeating questions anyway. A person can focus objects when they lie, are we together now? When they lie beyond what? 75 cm from his eyes. So now, if that person can focus, what do you think is happening to this person? What do you think is happening to this person?
Long-sightedness.
Long-sightedness, which means that person can only see, cannot see things that are short, isn't it? That are close. Good. So now, they said that this person, so what does this guy need? This guy needs a converging lens, isn't it? So remember that your converging lens, that the focal length is always positive, right? Focal length for a converging lens is positive. Now, when they lie beyond 75 centimeters from his eyes, remember that the distance vision is 25. That's the least, what do you call it? The near point, right? Should be 25. So now, how do we solve this problem? All right. Now, we have that, we should make use of our formula as usual, right? 1 over f equal 1 over v plus 1 over u. I will follow you now. Now they said the person can focus this when they lie beyond this. The focal length of the lens required to reduce this less distance of vision is what? Right? And I'm looking at a converging lens, isn't it? Right. Now, our u, usually our u will be what we use as our standard. That's those near points. If you are talking about short-sightedness, then you're going to be using infinity. Is that okay? That's the farthest, the far point. Your far point is infinity. That's the basics or the reference. Your near point is what? Is 25. So we're going to be making use of that to solve our problem. So our u now, which is the object distance, is going to be what? Minus 25, right? Then the what do you call it? V is what again? The image distance is going to be minus 75. Then we're looking for what? The focal length is what we're looking for. Focal length that will give us what we seek. Now, that said, let's apply our formula. I have 1 over f equal 1 all over minus, what's that value again? That's minus 25, right? Plus 1 over minus 75. So once you work this problem out for us, 1 over f is more like saying minus 1 over 25 minus 1 over 75. Anybody working it out? Very fast, please. Give me your answers. Your answers, please. Can we have our answers? Can you still hear me at all? I need to solve this, but I don't know how to go about this. And I don't know if they're going to bring this thing back. Let me try solving again. Let me just try. Okay, so go ahead and give me the final answer, please, while we try to resuscitate our MTN. A. So, but give me the value now so we can actually save it here for others that are going to make use of it. Minus 125 minus 25 minus 175. That means add them together. 125, 1 over 25 plus 1 over 75. What will it give us?
Well,
anybody? Which one is 25? Yeah? Why is this thing not working now? I'm sorry, guys. So let me focus on what I'm doing so I don't make mistakes.
So I think the U is positive.
This is what?
I think the U is meant to be positive.
It's meant to be positive. Even if you make both of them, you still have to get the same thing now. Minus, minus. The answer will now, if you bring the minus, invert it. It means that f, your focal length, we're using converging lens, isn't it?
Yeah.
And everything
side.
about
Yes, I think it's meant to be plus U then minus V.
Minus what?
I mean, the image distance will be negative and the object distance.
See what will happen. See what will happen there. Even if let's forget about this negative stuff we're doing now, right? So let's just work with. Let's work with this. Just work with this. Look at what I'm saying. You know, you're working with. Let me just give you a formula that works, right? Without whether you want to use this and the rest of them. So now for that side, for that long side, we have that 1 over f. Will just be equal to 1 over the near point of that person. Minus 1 over the normal near point. Is that okay? If I don't want to go into detail, if I start explaining all of these things now, right? Remember that there's converging lens, there's divergent lens, and the focal length differs. When it has to do with the image distance, object distance, we have to take note of that. Very well, good. So now that will be 1 over f equal to the near point is what? his own near point is 1/75 minus his normal point is what? Normal point of the eye should be 25 here. So 1/25. Someone should punch, please. LCM, or I know we can go like this: 1/4 equal to 1/75 minus, multiply here by 1 by 3, multiply here. I'm using equivalent fractions now. So that means I'll have 1/f is equal to 1 minus. Don't worry. Just follow through. Just follow through. Just follow through. Equal to 1 minus 3 all over 75, because this one also is 75. So 1/f is equal to minus 2/75. All right. So now, what will be the value of f now? 1/f.
So I'm getting 18.75.
18.75. So, but you should have a minus sign now. Is it 1/f is 18.75?
Yes. No, F,
Okay.
I mean.
F itself. Okay. So now, so that f is equal to minus 18.75. So f equal actually 18.75 centimeter. So this the signs are basically, these are sign conventions that we'll make use of. All right. So remember now, can we go back? Who can remember? For converging lens, what did we say for converging lens? The image distance, object is everything is positive, isn't it? Can we remember? Should I go back to that slide? Rachel, were you in our class when we treated that? Rachel? Were you in our class? I don't think you were there when we treated that, right? I don't think so. So that's the same thing. Or look at what you're going to do. I don't want to confuse you guys because of Rachel, for the sake of Rachel, but Paul and others, I know you understand what I'm saying, right? So now look at what you're going to do. Now, since you're making use of converging lens, everything that in your converging lens will give you what? A positive. Everything is positive in converging lens, isn't it? Both the focal length. Is that also? Converging lens, everything positive. Paul, give a thumbs up. Good. So now let's just go ahead. Rachel, even if you do, even if you do 1/f, right, is equal to 1/u plus 1/v. 1/f is equal to 1/75 plus 1/25. Sorry, the other way around. Anyone? So we can follow through what it should be. 25 plus 1/75. 1/f is equal to, what will it give us now, Paul? Can you add?
F will be 18.75.
18.75, right? So, but this will give us, let me apply equivalent fraction. So I have 1 times 3. Rich, are you following? 25 times 3 plus, let me solve it to the end, Paul, so that she'll get to understand better. So we now have 1/f. Don't allow this thing confuse you, please. 1/f is equal to 3/75 plus 1/75. So that I have 1/f is equal to 4/75. So that f will be equal to 75/4, which will give us 18.75 centimeter. Is that okay? And based on the convention, if I use the convention that converging lens, everything in converging lens, both the distance, the focal length, everything is positive, right? You have that your f is positive. So it depends on the sign convention. Is that okay? Are we together? Rachel, your hands are up.
Yes, sir. Please, I want to confirm. I saw in a YouTube where they say that for converging lens is negative sign. Then for the other
Good.
one,
That's what I'm saying. Let's go back to the reflection through lenses, right? I'm glad the slides are here, so I will put you through something that we did that very day. All those things shouldn't be something that would confuse you at all. All right, so look at what I said here. All right. I gave key points. I'm coming. Let's get that sign convention. Very important. All distances are measured from the optical center of the lens. The distance of real images, objects, foci are positive, while those of virtual images, object, and foci are negative. Focal length of a converging lens is positive. Focal length of a diverging lens is negative. It depends on the sign convention you want to use. It's going to balance up. Just like clockwise, people will tell you that clockwise motion is positive, anti-clockwise is negative. I don't know, does it make sense? Paul, go ahead. My own meetings, Paul, go ahead. Ask your question.
Sir, in the where I got the questions from.
Yeah, what did they say?
When they solved the answer was 37.5.
37.5? What did they do?
They used negative 75.
Good. Go
So
ahead.
if they do this UV over V plus U equal to F, they will have 1,875 divided by divided by 50 minus 50 divided by minus 50. That's minus 1,375 divided by minus 50. That will give us 37.5.
Can you send that to the group?
All right, sir.
So let me see it. Then let me look at our textbook as well. Yeah, so we can verify some things. All right, so now we have, let me go back to that slide, and I want to check something. Then if it walks through, then we have nothing to worry about. So let's check. Just a quick one from my end. 1 over f, 1 over v plus 1 over u. The distance is 25. So 1 over f. Your sign did not cross equality to change. No, there's nothing to cross because you're looking for 1 over f. It cannot change, okay? Minus 1 over 75. 75. Right. So minus 1 over 75. 1 over 25. 2 over 75. 37.5. Okay. Now, Paul, I get what you're saying now. I get what you're saying completely now. Yeah. So what they did was that the V was minus 37.5, isn't it? Minus 75. I think. Can you hear me? Hello? Good. Yeah, Paul, go ahead and talk. Yeah. Yeah, go ahead. Your hands are up.
Yes, so sir, I've sent it, and like you saying, this this is what I was saying. This is what they did. So it's minus 1 over 75.
Plus 1 over 25, right?
Yes. So it will now have negative over negative. Now, so it will now be 1,875 over 50. If the
Negative over
negative
negative. No, it cannot be negative over negative. Now, I just saw something from the textbook as well. Similar question to this. But that one, the value of V was 37.5.
Yes.
Yes, was 37.5. So one of them, that I need to check out for these signs again so it doesn't confuse us, right? We have to be very careful on this sign so it doesn't confuse us. We have to be careful on signs so it doesn't confuse us. All right. This is a question we are solving. Okay. So we have this focuses on this. So from the test we have minus this. Just 2 seconds. Let's be sure on this so we don't make mistakes. Is that okay? Let's be sure on this. Okay. Okay. So for both of them, they use a negative sign, isn't it? 4.
So I think the reason why the U is negative is because it's the normal
See what will happen here? To solve this problem of sign. Are you there? To solve this
yes, sir.
problem of sign, yeah? To solve this problem of sign, use this formula. All right, because in exam hall you have other things to battle with, right? So you won't be wrapping your head around these things. Use this, right? So use that you have 1 over the near point. Are you listening now? Over
Yes,
1 of the normal point, 1 over near point minus 1 over the normal near point. All right. So now, just use that formula so that it solves this problem without us getting confused.
Sir, I think I now understand why the U
Okay,
V is
go
negative.
ahead. Go ahead.
Because from the lens system, V is negative when the image is the object is focused or the image is formed at the back of the film, at the back of the lens. So, and
Images.
for normal
Wait.
the image is at the back,
Images what?
is formed behind the retina. So that's why I think that's
Behind
why it's negative.
the V is negative. Image
Yes.
behind retina. That makes sense. Let's look at this reflection through lenses. Image behind retina. So now, distances of real image, while those of virtual images, which means it's a virtual image.
Yes.
It's a virtual image. Yeah, that covers it. It's a virtual image. Yeah.
That's why it's
So it's a
blurry.
virtual image. Yes. So that's why, yes, it's a virtual image. Makes sense now. It's a virtual image. So, and that is what we need to hear, right? So now, and this is where these rules start making sense now about all of this. So distance of real images, objects are positive. Why those of what? Virtual images. So we expect that image to be a virtual image. Are we together now?
Yes. Yes, sir.
All right. Richard, are we together now? Are we together, Rachel? I think we've solved that problem. So please take note of this. Let me add it to your optical stuffs now. Let me add it now. So now, take note of this. Please take note of this. That solves our problem. All right. I think those guys, they just use that example in the textbook, basically, because turning both of them negative. Can you hear me now? Turning both of them negative. Are you listening, bro? Paul, doesn't make sense, right? So now, what you need to know is that these lenses, both of them, the lenses used in correcting this eye defect, they form virtual images. Are we together now? The lenses that are used to correct the eye defect forms what? Virtual images. All right. So correct, from virtual images. So please, can you take note of that? All right. Whether you're using your hypermyopia, you're using all of them, the correcting images are going to have virtual images. All right. So that said, I think we can tackle that problem hands on now. Yeah. Confusion can be very good sometimes. So you can actually get the root of your problem. And I don't like assumptions as well. All right. So let's go. Now, based on that, we're expecting that our U, right? U is equal what? 25, isn't it? U equal 25. Now, since we're using a converging lens, right? we'll have that correcting lens or correcting lens for eye defects, like your short / the long sight, will be a virtual image. Now, from our sign conventions, right? Virtual images are negative, right? So we'll have that V is equal -75. So we'll have that 1 over V, 1 over F rather, equal to 1 over V plus 1 over U. Then Richard, you're saying about sign crossing over. I don't understand what you mean by sign crossing over. There's nothing the sign is crossing over to do now. Is he crossing the Red Sea when the number is just there with you? So this is 1 over -75 plus 1 over 25. So this will give us, let me use my calculator straight up, there's no time. Richard, this is now we cannot be crossing over now. 1 over, I wonder where you wanted us to cross over. Mess, are you in this class at all? When it comes to formula like this, Mess will just be very calm. 1 over F, it simply shows your fear for mathematics. Meso. This will give us
what math did to me last year.
You said?
I used to like maths until last year. Maths humble.
What happened? How did they humble you?
Like I covered the textbook for maths among all subjects. At the end of the day, I got the lowest in maths.
Are you serious? And is that why you left it?
Test I got 25 out of 100, and exam I got 45 out of 100.
That's an F, you know. All right.
All right. So
converging lens. Positive. All right. So that makes sense now, isn't it? And Richard, converging lens are always positive. From that, our lens distance. All right. Converging lens positive, diverging lens is negative, virtual image is negative, real image is positive. So take note of that. Try and watch the recording on that very particular video. All right. So I think we've answered that one. So the answer should be this, and it's going to be a convergent mirror, convergent lens, I mean to say. And the focal length is going to be positive. Which of the following statements is correct about a long-sighted boy who does not put on the glasses? Very fast, very fast. What happens to a long-sighted boy? Parallels are formed behind his retina, isn't it? Right? The rays of light are formed behind his retina, right? Good. From behind his retina. All right. So the next one, in a compound microscope, the objective lens has a shorter focal length than the eyepiece, which is concave. The objective lens has a longer, have a longer focal length than the eyepiece, which is convex. The objective lens have shorter focal length than the eyepiece, which is convex. For compound microscope, what happens there? The objective lens have a shorter focal length than the eyepiece, which is convex. Both of them are convex lenses now. Both of them are convex, isn't it? For optical instruments. Yeah, they are both convex. Now, for compound microscope, like what we saw, has a long. This is astronomical telescope. So for compound, combination of two, both lenses having short focal lengths, right? From the textbook, they highlighted short focal length. So this one, they are saying the object lens has a short focal length than the piece, which is concave. No, has a long focal length than the eyepiece. Both of them are convex mirrors, convex lenses. And because of that, I will actually not pick anything here because both of them are convex lens, right? They are all converging lens. Both of them, both the objective lens and the other one? Objective lens and the eyepiece lens. They are both the same thing. In a microscope, the eyepiece lens merely acts as a what? It acts as a what?
Magnify.
Go ahead.
I think it's magnifier.
Yeah, it's magnifier actually. It has to magnify the image because on a simple microscope, remember what happens in a simple microscope? What happens? It has just one lens, isn't it? It has just one lens. So, but when you bring towards two lenses, what happens is for us to have a better offshoot, right? That is why we even think about getting the second lens, which is your the eyepiece lens. Richard, are you following? Mesa, is he following? Yeah, I hope we're still following. How many questions do we have to go? 1, 2, 3, 4, 5, 6, 7, 8. Man, I'm already tired. Well, let's keep going anyway. Let's see if we can finish it. Anyway, we stop. I leave it to you guys now. Right. So what does the next one say? A nearsighted student has a near point of 0.1 m and a focal length of 2.0. What is the student's far points? So some of you guys should work that one out from what we did. All right. Sorry, I forgot to mark this one. This is magnifier. So now they gave us something here, a nearsighted person. When you hear nearsighted, what does it mean? When they say somebody is nearsighted?
Short-sighted.
Short-sighted person, yeah. So he has a near point of 0.1, right? And then a focal length of 5.0. So what is the far point? Rachel and Co, you guys should work it out, please. What is the far point? So who can tell me what you are solving for? Are you solving for U or are you solving for V? So let's give you guys a clue. Are you solving for U or are you solving for V? Which one? Solving for V or solving for U? Rachel? Meso? Solving for V or solving for U? Which one?
I don't understand this question.
All right. So first of all, how do we correct? Which lens do we use in correcting a short-sighted person?
Concave lens.
Concave lens, which is divergent lens. So it means that this is a divergent lens, right? And for divergent lens, focal length is what?
Negative.
Negative. Negative. So it means that our F is equal to what? Minus 5.0 centimeter. Hope all of us were on the same page. But remember that this thing is tricky. They gave us this guy in meter, right? They gave us that guy in meter. So which same thing as saying that F is equal to divide 5.0 by 100. What will they give you? 5.0 by 100. Or instead of converting that one, in exam hall, I think
in centimeter.
Let's use in centimeter. I think that will be better. So that will give us 10, isn't it?
Yes.
Okay. So let's leave it in centimeter, please. The other one will be more difficult. So F equal to minus 5.0. How many times am I writing F? Now we have our near point. Remember, this is a short-sighted person, right? Which means he cannot see something that is what? Something that is what? Far. Now, our U for far distance is what? Is infinity. Isn't it? For a far person, our U is infinity. Is that not so? All right. Now, we're not looking at what is the student's far point. Mesa was correct when she said that we're looking for what? V, right? Very correct. But I know she was guessing actually. She wasn't too sure. And that's why she didn't say it so loud. All right. So now, having highlighted some of these things, the first thing we're going to do now, we have that 1 over V is equal to 1 over F plus 1 over U. So this is minus 1 over 5 is equal to 1 over V plus 1 over infinity. 1 over infinity will give us 0, isn't it? Minus 1 over 5 is equal to, yes, and the image, yes. Plus, this is 0, all right? So it means that, Richard, yeah, hope I answered you. 1 over V is equal to minus 1 over 5. So that the V is equal to what? Minus 5 over 1, right? So as always, we expect that guy to be a virtual image, minus 5 centimeter. So V is equal to what? 5 centimeter. Remember that why we have this negative is a virtual image. Is that okay? So all you need to always remember is for each one, which one is steady? U is always defined. Why am I using infinity? I'm using infinity because this is a short-sighted person, right? And for a short-sighted person, the normal far point, right? So this is myopia. Oh, God, I spell myopia again. Don't make I write short-sighted, I beg. Short-sighted. All right. So for short-sighted person, we have that the normal far point, our normal far point is what? You are talking about what? Far point, right? It has to do with the far point. So your normal far point for a normal person is infinity. Just like the normal near point of a normal person is 25. So U equal to 25 when you are solving for what? Long-sighted person. Then U equal to infinity, which is the far point, when you are solving for what? A hypermetropic myopia, which is a long-sighted person. Does it make sense now? Let's say I laugh, I'll bite my tongue. I'm tired already. All right, so that's it. Always remember this. So now that said, we cannot run away from it, Paul. So we still have to convert. So V is equal to 5 over 100, and that will give us 0.05 meter, because the options they gave us are in meter. So what? My answer is not in the option? Or have I done anything wrong? 1 over V. 1 over V is minus 1 over 5. 1 over 5 is what? It's still the same thing now. Isn't it, guys? 1 over 5 will give me minus 0.2. Am I making a mistake here? 1 over V equal to this. Okay. 0.05. Well, why is it that we did the right, you know? Which other method do you want us to use right here for this particular problem? Or have they started with that thing they did the other day for the past question? Have they started again today? The near person is 0.1. If it's 0.5.0, so 0.1 times 100, we have 1 over 5. Okay, the near point of 0.1 and the near point of 0.1. What is today's far point? Oh, wait, guys. Let me observe something, please. So 1 over minus 5 is equal to, now they say what is the student's far point, right? They said has a near point of 0.1. Do we have any business with his near point? Do you have any business with your near point? Okay. All right, if that's the case, that means has a near point of this of 0.1. We're looking for his far point. You must say the answer to be what?
So
Yes.
I think the answers that is here in the app, when they solved it, they used 0.1 as the V.
0.1 as the V.
Yes, since it's long-term short-sightedness, I'm talking about it. So
yes,
0.1 is the V. Then the U
is what they are looking for.
What we are looking for, yes.
Find the what is its far points. Okay, as a focal length of this. Okay, why I will agree with them is because since the focal length has been given to us already, assuming we are looking for the focal length, and they told us that this is this person's far point, like they've given us the far point already, right? Which means they've given us the value of V for that person, right? But the challenge, they said this has a near point of 0.1. You know, the near point simply means the closest he can see.
Yes, sir.
You get the point now. So that's why, to some extent, and what they got was 0.1, like Mesa said.
Yes, they got 0.1.
So Mesa, where is your 0.1 coming? My goodness. Some of these problems can be equal infinity, short-sighted for far point. I think I'm overinterpreting this actually. I think I'm overinterpreting. Basically. I think I'm overinterpreting. The near point of 0.1. What is the student's far point?
They gave us what is it called? The other one in meters and the other one in 5.0 cm. So we have to convert the one in meter to centimeter, so it will be 10.
And anyone you convert is still the same thing. We use 10 now. Anyone you use. Bro, Paul, what did they convert? Did they convert that 5 cm?
They use centimeter. They use centimeter.
And they use 0.1.
Yes.
That is not possible now. That's physically based on dimensional quantity is purely incorrect.
No, they later converted to meter back.
No, you don't get my point. You cannot be solving directly with. They solve directly. So what you are trying to say that they did -5. They did this, and I'm writing now, equal to 1 over 0.1. Right?
No.
Plus,
they converted 0.1.
Good. Now you're talking.
Converted 0.1 to 10 centimeter.
Good. So now it's going to be 10 here, right? Then plus they are now looking for 1 over. This is the U, right? This is their U. Now for V. So minus 1 over 5 is equal to 1 over 10 plus 1 over V. So 1 over V will be equal to what? Minus 1 over 5 minus 1 over 10. So if I'm to simplify this thing further, I should have that 1 over V is equal to, I'll multiply here by 2. So I'll have 10 here minus 1 over 10. So that 1 over V is equal to minus 3 all over 10 times 2 times 2. Minus 1 over 5, you move over to the other side. All right. Then we'll have, I'm doing the right thing, isn't it? Or didn't they account for the negative sign? Or Paul?
So should I read out what they did here?
Yeah, did they account for the negative sign for the focal length?
The focal length, no. They did not.
I will do my research and get back to us on this. Let's be sure. Sometimes I don't really trust, just like what happened the other last time, and we saw that they were incorrect. So let's relax. Let me review things on long side short. I'll send the formula to the group. Is that okay? Right, yeah. Let me review. Okay. There should be one formula connecting everything, please. it's getting messy. Yeah.
What I noticed is that in patterns for long-sightedness, they give us our near point. Then we need to find the focal length. But for short-sightedness, they give us far points.
Don't worry, I'm going to do a better research on that, right? Yeah. So that we'll have a specific. I don't want us to learn it that way. It should be definite. This is physics. Physics does not change, right? The concept is still the same. So I'm going to do my research so we can have a comprehensive overview of everything. Is that okay? Yeah, I think that works better. All right. Yeah. Yeah. So I will check. And I think yes, I will check on that, please. So we don't make any. I don't want us to make the mistakes are becoming so much, which is not acceptable. All right. So an observer with normal eye view, are we there? With normal eye views an object with magnifying glass of focal length 5 centimeter. The angular magnification is dash. Are we there now? Are we listening? An observer with normal eye views has an object. I'm going to check that formula straight up, yeah? So remind me, there are two of them, right? Regarding the calculation on that hypermyopia, yeah. So there are two of them. I will check it. An observer with normal eye views an object with magnifying glass of focal length 5. The angular magnification is dash. Least distance of vision is equal to 25. So they're asking us about the observer, and he has a normal eye view, right? And he's using a magnifying glass that has a focal length of 5 centimeter, and they're asking us the angular magnification is dash. All right, and the least distance of vision is 25. All right, so now there's a formula we know. I don't think I showed us that particular formula, did I? Connecting your least distance vision and your magnification. Yeah, I didn't do that. So now this should work for them, that M is equal to 1 plus D all over F. There should always be a formula for these things. I will check for the other one as well, please. I'll get back to us on that. So now for that magnification now, are we together? What's the value of D? D is 25, right? So I have, this is equal to 1 plus 25 all over F is what? F is 5. So that M is equal to 1 plus 5 and M is equal to 6 centimeter. Equal to 6. We are doing with magnification actually. So please take note of that. Then remind me for that hypermyopia and myopia, right? So M is equal to 6. Take note of this. There should be one formula connecting them, right? And I'm going to send it to the group immediately after now. So take note of this particular one. If you're dealing with the least distance vision and you're dealing with magnification, you have 1 plus D over F. Is that okay? Are we all on the same page now? A thumbs up if you're following. All right. So now this one says the diagram in the figure above shows the lens arrangement in what? Which one has this arrangement? We have a periscope, we have a binocular, we have binocular, we have astronomical telescope. So I want to see who answered this particular question. Remember, it has two lenses. It has two lenses. And you can see that the image form is inverted. Image forms is inverted. So which one is it? Image form is inverted. So who is going? Anybody? Richard, can you mute yourself, please?
I have answer.
Okay. I think it's compound microscope.
Anybody? The image? No, it cannot be compound microscope now.
Then it's astronomical telescope.
Astronomical telescope, exactly. You know the image is inverted. So once you see that inverted image, right? If you are viewing a telescope, are you seeing an inverted image? For those microscope before you get. So once the image, you can see that image is inverted. This is the image. This is where the image is formed. This is the image. Once you see that inverted, it should tell you that you're dealing with what? A telescope. What happens when a person with uncorrected hypermetropia tries to read a book? Is in your hands. You guys know this already. What happens to this person causing it what? Image forms behind the retina. All right. So you guys can handle that as quick as possible. Cylindrical lens is used for the correction of what we've answered before, astigmatism, right? Terrestrial, should I be marking this thing? Yeah. Okay. This one is formed behind the retina. All right. So we've answered this particular one. Then the next one says cylindrical lens is for what? Astigmatism. Hope you are following, guys. Then for this one, we have terrestrial telescope has one extra lens more than the astronomical telescope. The extra lens is for what? I want you guys to answer this one now. What's the answer to this one? Right. What's the answer? I said it. The terrestrial telescope becomes longer because of something, right? Because of something. Let me quickly review for you guys again. Right. Very important. Look at it here. B. Who is saying B? Right. That's the Meso, right? Meso said B. And we know why. So now we have, so that is to reinvert the image. Is that what I'm saying? So that it can be what? Erect, right? So please take note of that. Is in the slide, right? Meso said B, right? So erecting the image, right? Thank you, Meso. You're following, right? Which optical instrument can be constructed with convergent lens or focal length 50 and 5 cm? Two convergent lens. Two convergent lens. Focal length, one of them is big, the other one is small. Which instruments can be formed using this? Right? Now the next one says the eye controls the amount of light reaching the retina by adjusting the what? Adjusting the iris, isn't it? Then this particular one, this question of focal length now, is it astronomical telescope? Is it Galileo telescope? Or is it compound microscope or terrestrial telescope? Which one? Meso, which one are you taking? You said it's what? A, right? Astronomical telescope. Yes. One of the focal lengths is long, while the other one is short. Thank you so much. You are following. You are very good at theories. All right. So that's for that. So I'm owing us something, which I'm taking right away. Is that formula that works for near point, far point? So we'll be very sure on that. Study that kind of questions. All right. So I think that's all for today. Hopefully tomorrow I'm looking at, not tomorrow, on Monday. Oh, we are writing on Saturday, right? Next week. I see this Saturday. It's upper week, right? Good. So on Monday, we are going to have our class on electricity, right? So Monday, we'll have electricity. Is that okay? Yeah, Monday electricity. So let's run it out. Then I'm trying to get this formula for you guys right away. All the best, guys. I will see you guys in the next class. Any question? Remind me to, I'm checking that in now, please. Sorry about that error we ran into, right? It happens in class. So I want to give us a formula that works for everything, please, so that it doesn't get confusion. All the best, guys. Chuk. Right. Thank you, Paul. Then check up on others, please. How is Emmanuel? How is Emmanuel? How is Titi? How is Ferrami and the rest? I hope to give them a call later on. Well, now all the best, guys.